Welcome to Calbeckistan, a place where anybody can learn math. I'm Mr. Calbeck. This is episode 5 in our Solving Crash Course series. Today we're going to be talking about how to deal with fractions and difficult challenges that are mixed in with the kind of problems that we've already been doing. By the end of today, you are going to be able to deal with any sort of craziness that happens with fractions, and it's not going to be a big deal. Now this one, a lot of you are going to be panicking. Again, you see a fraction in the front there. Otherwise, this looks really similar to what we did on the last episode with distribution. And we have a number in front of the parentheses here. The only difference on this one is that it's a fraction. And again, fractions, don't think about them as fractions because that's when it gets really difficult. Think about them as division problems. I'm going to show you how this works. We're going to break it down a little bit, and I think you'll find this is far easier than you may have thought otherwise. Okay, and there's actually two ways you can go about solving this. But first, let's think about the division problem. What this really means is 1 divided by 2. And, remember this, there's no symbol between here, so this is multiplication. So what this really means when I distribute this in is I'm multiplying each of these pieces by 1, and I'm dividing each of these pieces by 2. So see what this looks like. 4x, I'm going to multiply that times 1, and I'm going to divide it by 2. The negative 6, I'm going to multiply by 1, put that in parentheses so you can see, and I'm going to divide it by 2. That's all I'm doing here. Multiplication and division, because remember, fractions are just division problems. So let's see what this is. 1 times 4x is just 4x. It's a Ninja 1. I don't even need to write it down. So then all I need to do is divide. 4 divided by 2 is 2x. Over here, same thing. 1 times negative 6, that's just negative 6. Negative 6 divided by 2, minus 3. Not that scary, right? Try not to panic if you see fractions out in front, because all it means is a division problem. Multiply on the top, I divide on the bottom. Now here, I've got one from episode 2, or episode 3. This is a really easy problem to do. I'm going to do the opposite, and I'm going to do it to both sides. I'm subtracting 3, so I'm going to add 3. And I end up with 2x equals 15. Divide both sides by 2. 15 divided by 2. You can actually leave it like this if you want to, because it's a division problem. It's a fraction. Who cares? Or you can divide it out, and you can have x equals 7.5. Either way is fine with me. Doesn't bother me. I don't like decimals if the decimal repeats or continues for a long time. If, though, it stops like this, just leave it as a decimal. But if it's going to be a horrible one, just leave it as a fraction. No big deal. Your teachers will think that you're doing a really good job with it. If you watched episode 1, we talked about the whole point of solving is we're trying to get one thing on, or we're trying to get the variable, in this case x, we're trying to get it by itself on one side. In episode 2, we talked about how we always do the opposite. Now check this out. This is being multiplied by 1 and divided by 2. This whole side is being divided by 2. What's the golden rule say? That which you do to one side, you must do to the other side. And right now the whole side's being divided by 2. So what I'm going to do, the opposite. Instead of dividing by 2, I'm going to multiply by 2, which cancels that out. Remember, it makes a 1. And over here, I'm going to multiply by 2. Now look what happens. This whole thing cancels out, which leaves me with a 1 out here. 12 times 2 is 24. This is looking a little bit different here, but notice, no more fraction. Now, if this was some other number on the top, you could still distribute it in, but it's a 1, so I actually don't even need to multiply anything. The parentheses aren't doing anything, so I'm going to get rid of them, and now I'm going to solve like normal. What am I going to do? I'm going to add 6 to both sides, and I've got a 4x equals 30. And then divide by 4. And again, this is just a division problem. If you take 30 divided by 4, you get 7.5. Or if you like fractions, you can leave it and reduce by dividing the top and bottom by 2 to get 15 halves. Again, totally different way of doing it, but because of the golden rule, whatever you do to one side, you must do to the other. Because this is being divided by 2, I multiply both whole sides. And you can be creative with this. Again, math isn't this one thing where there's only one right way to do it. There's tons of ways to do math. And in this one, some of you may have seen this at the beginning. That's awesome. Seriously, try something. Be creative. Don't feel like you have to be stuck in one way or another of solving a problem. You can always try a new way if the first one didn't work. All right, now this problem looks absolutely horrible. We have fractions all over the place. Some of you guys are having like PTSD from your fractions from 4th grade. And you're looking at this, and suddenly it looks super challenging. I'm going to give you a trick that will help you on most fraction problems, and you're not going to have to worry about them anymore. Remember, what are fractions? Fractions are division problems. And what's the opposite of division? Multiplication. So I want to think about, is there a way that I could do the opposite to both sides to get rid of all of these fractions? Is there a number I could multiply all of these denominators by and have them all cancel out into a whole number? Now let's look at this. And there almost always is, unless you get to some really complicated problems. You can almost always use this trick. I see here 2, 3, and 6, and I want to say, okay, what is a number that will divide evenly into all 3 of those numbers? And your number is 6. 2 is a factor of 6, 3 is a factor of 6, and 6 is a factor of itself. So let's see what happens here. Remember, we follow the golden rule, but let's multiply both sides by 6, because again, we're doing the opposite of division. On the right side, I think it's easy to see what happens. The 6 and the 6 cancel out. They make a big 1, leaving me with just 7. Over here, it's not as immediately obvious, but let's see if we can simplify it down. Remember, that 6 is being multiplied. It needs to distribute into both pieces. So the 6 is going to multiply times the 1. 6 times 1 is 6. If you want to remember that every number is actually divided by 1, so the 6 multiplies times the 1 times the 2, so it just is the same number on the bottom. So we have 6 over 2x. 6 times 2 over here is 12 over 3x. And that equals 7. Now remember, I can do this because I'm following the golden rule. I multiplied both sides by 6. You can do whatever you want in math so long as you follow the golden rule. Now let's look what happens. That's 6 divided by 2. Oh yeah. That's 3. 12 divided by 3? That's 4. And now suddenly your problem looks so much easier. 3x plus 4x equals 7. And we can combine like terms like we did before. 3x and 4x makes 7x and 7. And now we can divide both sides by 7. That makes a 1x. 7 divided by 7 is 1. You think you would have guessed that that whole problem was equal to 1 at the end? Pretty cool. All right, so remember, be creative. Remember that fractions are division problems. And don't be afraid to try something crazy. And here's the other thing too. If maybe you picked the wrong number, maybe you tried 3 to start with. And that's okay. You can always try a number, and if it doesn't work, try something else. Eventually, you'll come up with a number where you can get rid of all of your fractions. But remember, that number needs to be divisible by all 3 of these. Or it needs to be a factor of all 3 of those numbers. All right, that's it for today. Tune in next time for some really weird-looking problems.